Hi guys, BuildZoid here, and today we're going to be doing a PCB breakdown after a very long time. Like, it's been ages since the last time I've done one of these, and fun fact, I actually have plenty of material. It's just and you might be like, so why haven't there been more PCB breakdowns recently? And my response to that is because while I'm trying to shoot them, they just don't feel right as I'm shooting them. So hopefully that doesn't happen to this one. Um, yeah, and it shouldn't, because today we are looking at something where, like, this is a really interesting card, and I just want to talk about it. So this right here is the RTX 2070 Super Hall of Fame 10-year edition from Galax. The PCB pictures are, of course, from Tech Power Up, so huge thanks to them for providing high-res PCB pictures in their reviews. There's a link to the review of the card, to their review of the card, down in the description below. I don't work with Tech Power Up, okay? It's just like they give you permission to use their pictures if you just credit them, so I'm crediting them, and if you care about things such as thermals and, gaming performance, things that I just find completely, I just don't care. Like, I'm perfectly happy to overclock GPUs from 10 years ago because, in my opinion, those were more fun to overclock, even if they're slow. Anyway, you get the idea. Like, if you want that kind of information, there's a link to their review in the description. So with that out of the way, let's get into the power delivery, of course, because that's the only part of the PCB I do actually care about. Starting off with, and I guess the fact that the PCB isn't white. Like, I do actually have a complaint for that. Like, the Hall of Fame cards have been white for, like, ages and ages and ages and ages. And I think I think it's really cool that they were white. Okay? Like, because the thing is, like, I don't like RGB because RGB is such a non-commitment to a color. Like, it's the equivalent of just not making a choice at all, right? Because it's just like, what color is your product? Gray with washed out LEDs on it. And it's just like, great. It's exactly what I wanted. More monochrome products. And white admittedly isn't really a color either, but it's better than, like, everything is black and gray now. And so I'm kind of sad that Galax has basically gone and done another black and gray GPU like everybody else. But hopefully this is just a one-off for the 10-year edition, and the other Hall of Fames don't end up being black as well, because like, well, they're like, everything is black now. I like the fact, like, honestly, I think it would be really cool if we could get a high-end GPU with a red PCB, um, like an extreme overclocking focused red PCB GPU. I think that would be cool. I'm sure it wouldn't sell at all because too many people. Well, make it a 1,000-unit limited edition, and then it doesn't matter that it's not going to be popular with people who care about aesthetics, because there's only going to be 1,000 of them. Anyway, so. Yeah, I hope the black isn't permanent. I hope that they haven't decided to start making Black Hall of Fame cards all the time, and this is just a one-off. But at least we've still got all of the VRM, goodness that is to be expected from any Hall of Fame card. So, let's get into that. This right here is, of course, the Vcore VRM, because it's the largest VRM on the card. Then above that, we have the memory VRM. So it's this right here. It's VMem, which of course powers all of the GDDR6 memory chips. The Vcore powers the GPU core. Then over here we have some minor voltage regulators, which I don't know which one's which. I also don't really care that much, but there's going to be a 1.8 volts rail. There's going to be a PEX rail. And so that's like PCIe interface. 1.8 volts is for the GDDR6, as well as the BIOS chips, that kind of thing. 5 volts for the USB VR link thing on the rear I/O, which I don't care about. There's also going to be a 5-volt voltage regulator somewhere in this area. The card comes with an OLED screen on the side, so there's a lot of unnecessary garbage in this area for powering that OLED screen. Which is it's just garbage. It's like if you take the heatsink off, the screen's not going to be attached anymore. So useless garbage. Well, no, I actually think the OLED screen for monitoring things, that's actually a bit more useful than having the blinky Christmas tree light up hardware everywhere. But at the same time, I feel like, well, I honestly would have preferred just like 7-segment displays for displaying voltages, just like soldered onto the PCB instead of built into the heatsink. But you know, like you can still do that with the OLED screen. So I'm just being salty that OLED screens are expensive. So and it's not like I'm going to buy one of these anyway, so why am I complaining about that? At least I'm not going to buy one of these unless it shows up on eBay really, really cheap in a couple years. So anyway, but there's a bunch of circuitry down here for the OLED screen, but there's also going to be a 5 volt regulator over here for the power stages, because the power stages run off of 5 volts, not off of 12 volts, not off of 3.3. So you do need a regulator to generate 5 volts for them, and it can't also be the same regulator as the USB connector because I don't actually know why. I've not bothered to check the specification for USB Type-C for why that would be a bad idea. Anyway, so yeah, that's kind of all the different voltage regulators on the car. Well, I've not even highlighted all of them properly, but that gives you some idea of the different voltage regulators that are present on the card. Other features we've got, like I've already mentioned the OLED screen, so yay, there's, well, it's not RGB though, like it's just monochrome. Anyway, there is a screen on the card. You do also have voltage read points right up here. This is, I don't, like, this style of voltage read point I'm not a fan of, because basically these force you to solder wires to the GPU, and at that point I feel like, well, what's the difference between soldering the wires right behind the core versus over here? Right? Like, you're still soldering wires to the bloody card. Like, your warranty's gone as soon as you do that. Because once you get tin on a solder pad, like, you're not getting it back off. So, and these are not tinned from the factory. I feel like they should have put a little connector on that. That I think would, and then like little, like part of the accessory pack should have been little like probe meter connectors for whatever header they had on top of that. But yeah, like the only company that consistently does that is EVGA with their like Probit connector. So yeah, like this is better than nothing. Most cards come with nothing. I guess if you don't want to, spend time figuring out which exact multi-layer ceramic capacitor to do your measurements from, that's more convenient. Anyway, on the other side, we have a full speed fan button. You might be like, why on earth do you need one of those? It's actually really convenient if you're just doing like testing on air cooling. You can just press that button and the card is never going to ramp down the fan speed. Obviously, like that I feel like is more a feature targeted at like binning, like for binning cards for extreme overclockers. Though, yeah, like, because it's not really a feature you would use if you're a gamer, because normally 100% fan speed, like, depending on the choice of, like, the thing, like, my personal opinion is having fans with a low RPM cap is just, like, that's a negative. That's a downside, okay? Like, I get it, at 100%, if you have less RPM, the fans will be quieter, but have you heard of PWM control, right? So, I prefer it if you can just whack the button and it goes up to like 4,500 RPM or something stupid like that, because then it's just like, yeah, in a scenario where you don't care about noise, you get way more cooling, and that's just like, yay, more RPM, more airflow. Why wouldn't you like that? Assuming, you don't actually care about the noise for like benchmarking runs, that's perfect. Anyway, also get a dual BIOS, but well, they had plans to put dual BIOS on the card, and then they decided not to, which I assume it's a very much a case of like it's an Nvidia GPU. Realistically, you're not like you don't mod BIOSes for RTX 2070s. Like that's just not really a thing as far as I'm aware. So there's not really too much of a point in including dual BIOS. At the same time, I feel like it would have been a good idea for like it's a Hall of Fame card. That's one of those things that should be on there in my opinion. Like even if nobody was going to use it, like even if the extreme overclockers aren't going to use it, it's just like it doesn't really hurt anything by existing. Kind of like the OLED screen. Except, well, the OLED screen hurts the price tag significantly. Similarly, over here, we have another missing switch, which I think was probably for something like an LN2 mode, but, like, well, that, I guess, like, the issue is getting Nvidia to approve extreme overclocking cards is a real pain. Like, that's the main reason why, like, the Lightning series and, like the Matrix series and the Lightning series of cards have become well, the Matrix... The latest Matrix is a joke, and the latest Lightning also a joke. And the reasoning for that is like getting Nvidia to approve proper extreme overclocking features is just an absolute nightmare. So nobody, like most companies don't bother anymore, and there's just like Galax and EVGA somehow managed to get Nvidia's approval for at least some cards. And I guess this one didn't quite make it because, yeah, that switch, like, I suspect that was meant for some kind of extreme overclocking feature. They were like, and then Nvidia was like, nah, you can't ship a card with that. So that's a shame. But yeah, at least Nvidia approved the power delivery for this, and the power delivery is great. So let's talk about that. The Vcore Vrm is an 8-phase controlled by this chip right here. And the chip right here, that is an XDPE 10281 from Infineon. Which, if I'm not mistaken, this can go up to 10-phase configurations, but here it's running as an 8, which I've already actually written that down there, so there's no point running it up here as well. But yeah, that's an Infineon controller. It's one of the latest controllers that Infineon makes, and I think this is one of the from the same series. This is from the same series as the XDP E132G5C, which is that 16-phase monstrosity that we've been seeing on some motherboards now. So I do believe this still has the same upgraded voltage monitoring circuit capabilities and better voltage control capabilities. But the thing is you actually I'm not sure that that functionality is implemented. It's optional. A lot of the really cool advanced power manage advanced voltage control features that come with a lot of different voltage controllers out there, they don't necessarily get enabled on all of the products that use those controllers because they're not necessarily they're often not officially supported by, say, Nvidia or Intel or AMD. And then it's just yeah, if you enable it, it's technically not within specifications, even though it should help with power delivery. So a lot of the time you'll have features that is well, technically it could do this, except we can't enable that. So that's a bit of a shame. But I don't know the specifics of how exactly this chip is implemented here, but it is a very capable chip. It just depends on what Galax was able to do with it. But this is not they're not cutting corners by using one of these by any means. So anyway, and for the memory VRM, they're using an MP2884, which also is a not the most cost-effective choice for just memory power delivery, and that's running as a 2-phase. And that's a high-end digital controller from Monolithic Power Systems. Unfortunately, I can't get any details on that chip whatsoever because it's a Monolithic Power Systems part, and yeah, getting details for their stuff is a nightmare. It's almost as bad as high-end Infineon international rectifier parts, except those are a bit more common, so I have my sources for those. But for Monolithic Power Systems, it's just nope, no sources. Anyway, back to the Vcore VRM. I just realized that since I haven't done one of these in so long, it's I'm now doing and first how many controllers, then no, I should have done entirely the Vcore VRM and then moved on to the memory, but it doesn't matter. For the actual power stages, we are looking in the Vcore VRM, we're looking at a bunch of TDA21470s, which I can talk faster than I can write, which is not surprising for anybody who's been watching my videos for long enough. So yeah, TDA21470s, these are Infineon / International Rectifier parts. They have the International Rectifier logo on them, but International Rectifier is owned by Infineon, so same thing. Either way, these are 70 amp smart power stages. 70 amp smart power stages are smart because they integrate better current monitoring, which you also need newer voltage controllers to take advantage of that. So yeah, better current monitoring, built-in built-in temperature monitoring, and built-in over-temperature protection, over-current protection. Basically, a bunch of features that previously you would have to implement with external circuitry to your power stage. Well, now it's just built into the power stage, and that's why it's smart, because it simplifies the VRM design, and essentially there's a lot more functionality built into it, and the various protections that they come with prevent them prevent a lot of potential failures that you could run into. So that's the TDA21470. And the end result, this is an 8-phase of these. End result is that this VRM is very efficient. Now, admittedly, this is not the highest phase count I've seen on a 2070 Super, but realistically, you don't need more phases. And this is one of the things is like there's a lot of GPUs out there where you'll just get phases for the sake of having phases, and then they'll just like they won't actually bother with some of the optimization. We'll get to the things that I really like about this card's power delivery, that a lot of cards, like, they might have more phases, but they won't bother implementing what Galax has done with the power delivery here, which we'll get to after, memory power and all that. So anyway, the efficiency figures for this VRM running at 400 kilohertz switching frequency, assuming an output voltage of 1.2 volts, should be around 150 amps of current, producing about 11 watts of heat. So basically, that's really, really cold. 200 amps of current, this VRM should produce about 16 watts of heat, which is just like the thing is, these 70 amp smart power stages are very, very efficient. 250 amps of current output. Oh wait, nope. 300 amps there. For some reason, I decided to skip the 250 amp figure, but anyway, 300 amps, this VRM will produce about 29 watts of heat, and 400 amps, it'll produce about 48 watts, and for 480 amps, which is where the data sheet ends, they'll produce about 68 watts of heat. So basically, yeah, this is perfectly, like, you could do extreme overclocking on this PCB, no problem. Like, the power delivery is more than enough for even the most extreme LN2 overclocks, which is to be expected. It's a Hall of Fame card, so yeah. Great freaking, like, VRM. Though the thing is, I do feel like, well, it is a 2070 core. Like, these cores are pretty big, so it wouldn't hurt if there was more phases, but at the same time, it's just like, I think you'll see more benefit from what Galax has done in terms of the output filtering on this card compared to getting a card with just more phases. Because the thing is, like, it's actually kind of interesting. Like, just because the VRM runs cool doesn't necessarily mean it's good at power, like maintaining output regulation. Those two are basically relatively independent properties of a VRM. Is like you can have a really inefficient. Actually, fun fact: linear voltage regulators are horrifically efficient. Like, have atrocious efficiency, but they're really, really good at voltage regulation. Which is like, that's a massive advantage they have over any kind of switching regulator like we're looking at here. But we don't see anybody building, overclocking motherboards or GPUs with linear regulators for their main power rail, because it would just be completely uncoolable, and you'd be losing probably like 20% of the power being regulated or more would just be lost as heat, which is just like, that is not an option. Like, nope. So yeah. Anyway, for the memory VRM, we're looking at a pair of MP, of course, like monolithic power system parts, because the typical thing is if you're using a controller from one company, you're also going to use like drivers or like anything that has that does like control logic. It's going to use the same brand. So monolithic power systems controller, you're going to get monolithic power systems smart power stages. And in this case, that's MP8695 6 parts, which I really botched that part number because I should have said 86956. There, see, that rolls off the tongue much better. Either way, this is a 60 amp smart power stage, so same idea as the Infineon power stages, right? Except just slightly lower efficiency because they can't handle quite as much current. Though smart power stages, like, the interesting thing is if you compare a 60 amp smart power stage to like a regular 60 amp power stage, the smart power stages will generally still be more efficient, which is just kind of a neat thing. Is just they, like, for some reason they basically get classed as a, like, their average their current well, no, basically what I'm trying to get at is you can't just look at the current rating and go like, okay, they're going to have the exact same efficiency. That's not true. 60 amp smart power stages are more efficient than your usual 60 amp power stages that you'll see. So anyway, and then, we got two phases of these for all of for the GDDR6, which is just plenty of power. Memory is just not that power hungry. So yeah, which is also the reason why, this is two phases and this is 8. So yeah, anyway, let's move on to so basically, oops, what the hell? Oh, there we go. Um, so, wait, where was I going? Though, okay, actually, one thing I will mention about the memory VRM, so it's plenty of power, but it's not actually like a massive upgrade over what you'd get on like a reference card, because a reference 2070 would actually have the same two-phase memory power. And in fact, even the Vcore VRM is not really like the thing is recently Nvidia has really stepped up the build quality of their reference cards. So this is actually like these are still more efficient power stages than the power stages that Nvidia uses, but it's not like like in the past there were GPUs where like the Nvidia reference card was like half the power handling capacity of the custom cards, and this is not the case here. This is better than like the current handling capability here is better than reference, but it's not, you know, as much of a difference as it used to be compared to like if you look at it like a GTX 1080 versus some of the overclocking focused 1080s, like massive difference. Or like a 780 Ti reference versus custom 780 Ti's, or a 980 Ti reference versus custom 980 Ti's. And then with like the 1080 Ti, Nvidia finally started putting out PCBs that don't have god awful power delivery. And since then, it's become much harder to make. Like basically, the end result of that is that, like, yeah, you could like it makes it harder, I guess, to make a significant upgrade over a reference NVIDIA card in terms of power delivery these days, because like NVIDIA is now putting out cards that aren't terrible. Um, so yeah, like since the 1080 Ti, most of the 10 series is still terrible. It's just like the 1080 Ti, for whatever reason, NVIDIA was like, oh yeah, we're going to make a good VRM for once. And I was like, what? When did that happen? What happened to NVIDIA? How come the VRM isn't garbage anymore? Anyway, let's take a look at the back of the card. So the thing that I really like about the Hall of Fame cards is that Galax just builds these ridiculous output filters for their VRMs, which I'm a huge fan of. So that's exactly what we're looking at here. So for the Vcore VRM, we've basically got all of these bulk capacitors, right? So, and those are of course through-hole aluminum polymers, Nichicon FP series, 1200 microfarads. These are huge. Like, yeah, like that's just the best way to think of them. Is they're gigantic. 1200 microfarads is a very big capacitor for your bulk capacitance. Most cards you'll see, usually like normally you see like 820 microfarad capacitors, sometimes even smaller than that. But yeah, Galax like, and the crazy thing is this is not the entire output filter. Like they just have all of these 1200 microfarad FP caps from Nichicon on the front, and then if we go on the back of the card, we get into sort of the, you know, you've got your 330 microfarad SMD aluminum polymers. I'm assuming these are aluminum polymers and not tantalums, but because normally the tantalums have a more distinct packaging style from the aluminum polymers, and aluminum polymers are better than tantalums. Like you can get them in lower ESRs, lower ESLs, and they're also, well, actually, funnily enough, they're not necessarily cheaper depending on what exact spec you're looking for. But yeah, so these are 330 microfarad aluminum polymers again. And these are great. So really, like, compared to the through-hole capacitors, you're not necessarily going to see these having like a significantly lower ESR, but what they do have is a much lower ESL. So they have a much better frequency response. They're much better at filtering out high frequency switching noise, like say the stuff that a GPU core makes, which is why you have these sitting right behind the core. Those are there to soak up, obviously, the bigger, slower transients, but then you have like the really little multi-layer ceramics for all of the really high switching frequency noise that a GPU core produces. Anyway, so yeah, we've got these 330 microfarad aluminum polymers, then we've got these 0805 multi-layer ceramics, and they seem to be using multiple different capacitances of multi-layer ceramics because these are a different color, so that generally will indicate that, well, I would assume that that just indicates that they're a different material, so these are probably these might be a higher capacitance. Like, I'd suspect these are a higher capacitance than these. But either way, so the multi-layer ceramics are just like, so these have you know, similar ESR. Well, actually, ESR actually bottoms out at around 5 milliohms for basically any capacitor type, as from what I've seen, like reading through various capacitor data sheets. But you basically, as you get into the smaller and smaller multilayer ceramics, you start getting lower and lower ESL. So less and less parasitic inductance, which means the multilayer ceramics are better and better at, you know, dealing with the high frequency switching noise that the GPU core creates. And so having this sort of like the thing is like Galax is really mixing every type of capacitor they can, right? You've got the gigantic aluminum polymers on the front. Then you've got your SMD aluminum polymers on the back, which they have some in the VRM, then they have more going towards the core than some right behind the core, which is normal. Like that's normal for a lot of Nvidia cards to have SMD, you know, like large SMD polymers behind the core. But what isn't normal is all of these extra multilayer ceramics that they have on the power plane in this area. In fact, really, this part of the power plane is pretty unique because what you'll see on most cards is you'll probably see something like most cards, you'll see a configuration where like this is missing, that's not even an option, that's also missing, that's missing, this is missing, this doesn't exist either, right? So there, and now you'd have like most other 2070 Supers, except you might also want to remove some of the aluminum polymers, like some of the through-hole caps as well. So I'm a big fan of the fact that just Galax, when they do their output filtering for their GPUs, is just like they go really heavy on just, you know, mixing all types of capacitors and then just whacking on as many as is like obviously it looks like at some point they had a significantly like more in some prototype design, and then they were like, yeah, at this point it just doesn't make a difference. But I'd really like to see like a comparison of this card on an oscilloscope versus some other 2070 Super PCBs on an oscilloscope, because like, yeah, this is a really cool output filter for a 2070 Super. And you see this kind of thing on, well, you used to see this kind of thing on a lot of extreme overclocking cards, but well, like more recently the GPUs, like the thing is like a lot of the companies that used to do really cool extreme overclocking cards, they just don't care anymore about doing them anymore. So you don't see this kind of thing, and it's just like Galax does it, EVGA does it, right? Just look at the 2080 Ti Kingpin edition. Um, but yeah, so I'm a big fan of this. And then for the memory, they're still kind of doing the same thing. It's not quite as heavy though as like actually, yeah, no. For the memory, they're not doing it quite as much. So they have like this one over here, and then of course they have these two. Oops. They obviously have these two aluminum like through-hole caps over here, which are still 1200 microfarads. Anyway, then they have some more multilayer ceramics, and they do seem to have more multilayer ceramics in this than the reference Nvidia design. But overall, like, and this cap is, I think, unique. I don't think I've seen that on any other 2070s. Like, I did actually go and compare this against like a reference 2070 just to see if they did anything more to the capacitor configuration. But for the actual memory chips, they've not really done anything. Like the capacitor configuration you see behind each of the memory chips, that's the same as reference as far as I can tell. So that I'm a little bit disappointed by, because I did actually get to work on a reference 2080 Ti at one point, and one of the things I did is I just whacked a bunch of capacitors onto it on the memory rail, and it did actually overclock the memory better. Because I'm pretty sure Nvidia likes pinching pennies on capacitors. So yeah, so that's like, so you know, the output filter right at the VRM, cool. I think like I feel like there should have been more like maybe like a row of multilayer ceramics along this right here. Like they even, I'm pretty sure this is ground plane. Like they could have literally just put some, you know, power plane stitching in this area, and then just put a bunch of multilayer ceramics across that. Bam. And then it would get my seal of approval. But it might also be unnecessary. Like the thing is just like, at some point you reach a point, like eventually you reach a point where more capacitors does not lead to better overclocking. And once you're at that point, you're just spending money on unnecessary components. So I don't know, they might have actually tested some other capacitor configuration for the memory VRM, but like well, other capacitor configurations for the memory power delivery, but I kind of doubt it because unlike with the Vcore VRM, like in the Vcore VRM, we can see that, there's unpopulated capacitor pads just all over the place where I guess they came to the conclusion, yeah, adding these just doesn't do anything any longer. But you don't really, like, there's no options. Well, I guess those are options for the memory VRM right there. Actually, that looks like it might, that almost looks like that's Vcore power plane going up there. Actually, yeah, that's probably Vcore up there. And then this is memory. So that's a fun layout. Anyway, so yeah, I think the memory filter could have been more interesting, but this is a bit unique. But maybe like a big fat aluminum polymer over here for the memory chips that are here, so that when they try to pull a bunch of current, they don't have to like grab it from all the way over here. They instead have a reservoir sitting nearby. But oh well. Like the Vcore is very impressive. That is for sure. I'm a huge fan of what they've done for the Vcore, but the memory filtering is just like, yeah, this looks pretty similar to what you'd get on a reference card. Other things on the back of the card, here's our current monitoring chips. So those are on semiconductor, I can't remember the full part number, but they're 45491s. You can Google these. You'll get a data sheet if you need that. Then we have some chips for the power balance. Well, actually, these might be voltage regulators for the extra rails for like the OLED screen and stuff down here. And I guess those would be the controllers for the OLED screen over there. Anyway, what else is there? Yeah, so I think that's it. Right? Oh, and I guess, well, no, input filtering capacitors just aren't as important as the output filtering ones, so that's why I don't normally talk about them. But those are just more Nichicon FP series capacitors. Yeah, so, oh no, the one last thing I wanted to mention is they do like, I have a suspicion because I think Asus does this as well. Galax have shifted the core up, right? Like this core is actually, did they? Yes, they did. Like, their memory chips are way above the PCIe slot, right? Like, you can see that. Like, their memory chips are way above where the PCIe slot and, like, bracket ends. So, they've shifted the core up a bit. And my suspicion for why they're doing this, because Asus does this as well. And I've seen some people leave comments that it's like, oh, it's for the NVLink connector. But I don't really believe that because there's cards where the NVLink connector is just a mile away from the GPU core. So, I don't really think it's a concern for signal integrity to the NVLink connector. No, I think the main reason that like Asus and Galax do this is it actually makes the essentially it shortens the distance because you can see how we have the Vcore power plane running through this area. Right, you can kind of see it right there. So it basically shortens the distance from the furthest away phase to the GPU core. So I think it's a power delivery optimization of the power plane, which is why they shift the GPU core up. Because if you look at like if you look at a lot of other cards, their core is like here, and then their VRM just goes up to here, and they're just like, to hell with it. And then and it's even better when you get a GPU where the memory VRM is like behind the Vcore VRM because they no longer have space for a memory VRM. So it's just like, who cares about powering the memory directly, right? Just put the memory VRM out of the way. It doesn't matter. GDDR6 isn't that sensitive to power delivery anyway. Though there are some cards which will put the GDDR6 power delivery in this area, which I think is a good idea. You know, if you run out of space here, then that's a better option than putting the memory power delivery behind your Vcore VRM, just because it's like, well, a shorter power plane means less power loss, and that's good. Anyway, so yeah, that's the Galax 2070 Super Hall of Fame. And, well, in terms of actual power delivery, you know, it's a slight upgrade over what you'd get with a reference 2070 Super. In terms of the filtering for said power delivery, I'm a big fan because, like, this honestly puts to shame even some of the most, like, even some 2080 Ti's have in my like output filters that don't look quite this good. Though admittedly 2080 Ti's have like the really funky split VRM where you have, you know, like the VRM is on both sides of the GPU core. But anyway, oops. Yeah, like this is a really, really cool card. Like, it's just a real shame that, like, so, as far as being a Hall of Fame card, I approve of this being like getting the Hall of Fame name. It's not like the Matrix that Asus released, where it's basically a Strix card with a gimmick strapped to it, or the Lightning that MSI released recently, which just like shouldn't be called a Lightning in a million years. Like, I have literally no idea why they decided to call that a Lightning. Like, the Lightning cards used to do like I was just like, look at all these freaking capacitors. Like, that used to be Lightning cards. Like, Lightning cards used to have just insane capacitor configurations. They were ridiculous and awesome, and you had just the greatest VRM. And then you look at the most recent Lightning, and it's just like, the capacitor bank couldn't be like less impressive if they try. Like, it probably wouldn't work if it was less impressive. It's like that level of just like it's just some through hole caps and a couple multi-layer ceramics. And like, honestly, I'd rather have a reference card than the current generation Lightning, because Nvidia's reference PCB, like, I'm not sure if the power, like, I'm not 100%, like, there might be some improvements with the Lightning compared to the reference card, but in terms of capacitor selection, Nvidia did a better job than the 2080 Ti Lightning with their reference card than what MSI did for the 2080 Ti Lightning. So anyway, but enough about that. This right here, this is cool. I'm a big fan of it. So yeah, that's it for the video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon where you can support me directly. There's a link to that down in the description below. And other than that, there's the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. And both of those help out immensely with running the channel. So yeah, if you check those out, that would be great. And yeah, that's it for the video. Thanks for watching, and goodbye.